Hello. In this session, I'm going to go over an area within data mining called classification analysis. So far, we have looked at predictive modeling, where we're trying to predict what value a particular variable might get based on some input variables. In classification, we simply look at the data and try and group them based on some means of similarity, and there are two different methods that can be considered for classification: cluster analysis and association analysis. We're going to look at association analysis. All right. Well, one of the people would say the essence of data mining is the discovery of interesting, unexpected, valuable structures in large data sets. Now, the thing is that is kind of ideal, but that doesn't always happen. Now, if you got lots of data, then you're trying to expect data mining to find interesting results, then that's going to take really long time, and it'll be almost impossible to find anything. You might as well not even start at all. So what is pattern discovery? We start with some data and try and do some exploratory analysis. That's what it is. So some of the questions that can be answered by these techniques is, for example, you'd like to know if certain types of customers are more likely to pre-order books at a premium price, or I would like to know what kind of customers will be there at the food court in the mall on a Saturday afternoon, and will be families or teenagers or families with children. It'll be a good way to find out. Look at the cluster of customers, and or if you're a call center, you may want to find out what are the most common types of complaints that we get. So you can classify complaints based on some measure, and what is that measure? We don't know. We can let the data tell us what that measure is. Or the last point here: if a customer bought a product this week, what is it? Will the customer also buy another product next week? Which other product will he likely to buy? So, in other words, is there any kind of relationship between choice of one product to choice of another product? So that's what we're going to look at. All right. So what we're going to look at is we're going to use the market basket analysis part of exploration under using SAS data miner. Association analysis is what we're going to be looking at. So we'll start by describing some examples of association analysis may be useful, and then we'll look at market basket analysis, or MBA, and we'll look at how concepts like support, confidence, and lift are defined in terms of in the context of association analysis, and we'll actually later we'll do an exercise using enterprise miner. Okay. All right. So one of the most common application of association analysis is what's called market basket analysis. So what items are likely to be purchased together? That is a general idea. And if a product A and product B often go together, then probably the storekeeper might want to place more expensive alternative B to near a display of A, so that you can upsell to products. And sometimes you can, if A and B are bought together more often than others, then putting them on sale at different times can also improve your sales and so on. All right. And other examples would be in hardware purchases, lawn ornaments, and indoor decorative ornaments, or key cutting tools near paint or door hardware. These are placement related issues that can be answered if we have some insight into what two items are purchased together most commonly. So we're going to look at association analysis, and which is of course also known as market basket analysis, and it's fairly used, and it is not highly statistical, and but simply looking at the huge amounts of data and trying to use some basic concepts of probability, and so it's got a lot of different applications in banking, in telephony, and in processing text document, processing web data, and so on. All right, now the idea is we have different shopping carts, and so shopping carts contain products A, B, C, or the second shopping cart contains product A, C, D, and the third shopping cart contains B, C, D, and so on. Okay, and all right. So what we want to try and find out is we want to find out rules that X implies Y, and this means whenever there is an X, and there is a big probability that Y follows. Or if you look at the products in these shopping carts, we have products like A, B, C, D, and E, and given C, how often does A occur? So that's a rule that we want to find a number to. So we want to find some way of measuring quantitatively how often would A occur if C is given, or given A, how often would C occur. So we use some measures called support and confidence to quantify these associations. Alright, now here in this case we have 5 shopping carts: A, B, C, A, C, D, B, C, D, A, D, E, and B, C, E. These are 5 shopping carts with 3 products each. And each shopping cart, of course, is one transaction. There are 5 transactions. So out of this, we have A's in 3 out of 5, B's in 3 out of 5, and so on, simply by counting the number of A's in these baskets, and that is 3 of them, and number of D's in the basket will be 3 out of 5. 2 out of 5 baskets have E's, and so on. So that is simply coming up with the frequency counts. That's not any much problem. We want to calculate what's called support for A implies B, and the definition of support is simply number of transactions containing every item A and B over all the transactions. In the previous slide we looked at only one item at a time, but support simply wants you to look at 2 items at a time, combinations. So if you look at 2 items at a time, you'll find that A implies B happens, A and B happens together is 1 out of 5 times. So it's only the first cart we have A and B together. A and C together is in 2 carts, so cart number 1 and cart number 2. Similarly, I have calculated the support for different combinations. See, some are pretty low. Sometimes it can be 0, but in this case all of them are about 0. So D and E together appearing, I think I counted it only in the 4th card, so 1 out of 5. So support can be calculated simply as a combination, a count of the number of times the combinations of products occur together. Alright, the next thing is confidence. We have calculated support, and which is simply number of times A and B occur together. To figure out confidence, we have to come up with the support and divide that by number of times A occurred. Alright, so transactions containing every single item in A and B over transaction containing the items in A. Okay, so to do that we can go back and calculate our confidence. So A and B, A implies B, meaning we have the number of transactions containing every item in A and B. So A and B together happened once, 1 out of 5 times, and number of times A was found is 3 times. So 3 out of 5 is A. So the confidence of A implies B is 1/3. Okay. So number of times A and B together is 1/5. Number of times A happened is 3/5. So 1/5 over 3/5 equals 1/3. So confidence for A implies B is 1/3. Confidence for A implies C is 2/3. And the confidence for B implies C is 1. How do we get that? B and C together it is 3/5, and B itself is 3/5. So every time B happens, B and C happens. So B implies C has a confidence of 1. So this way we can calculate confidence. Okay, what next? And the confidence, when we calculate confidence, we can also calculate confidence for the same rule with the different product on the left side. So B implies A. To calculate B implies A, you find that it's 1/3, that's 1/3. C implies A is 1/2. D implies A is 2/3, and so on. All right. The next concept we're going to look at for understanding which rules are useful and so on is a concept called lift. Okay, and lift essentially tells you if two items kind of go together or not. There are a couple of ways of calculating lift. Confidence of A implies B over expected confidence of A implies B. Now it's the same thing as confidence of A implies B is given as a transactions containing every item in A and B over transaction containing item A, and expected confidence A implies B is simply the proportion of times B occurred. So the denominator is simply the proportion of times that B was seen in the entire data set. So looking at this, we find so looking at our data, our results, we find that A implies D has a support of 2/5 and confidence of 2/3. C implies A has a support of 2/5 and confidence of 2/4, and so on. We can also do 3 products at a time. B and C implying D, find that 1/5 is a support and confidence is 1/3. So the idea is, once you have a bunch of shopping transactions like this, you want to find which products kind of go together. You could just look at 2 products, or could look at 3 products or 4 products, and of course the more number of products you consider, the more time and expensive it is going to be for doing computations. So there are some algorithms that help you make things faster, and we're not going to go into the details of that algorithm. Now this concept of confidence and so on can also be figured from your regular crosstab or your contingency table. So in contingency table, if you remember from before, so here's an example of a contingency table where we have data on customers in a bank. So there are a bunch of customers who have checking accounts and a bunch of customers who have savings accounts. 500 of them, do not have either savings accounts or checking accounts. 3,500 of them have checking account but no savings account. 1,000 has no checking account but they have savings account. And 5,000 have both checking and savings account. So that's a simple, straightforward contingency table across tab. And we have a total for columns, a total for the rows, and overall number, there are 10,000 customers. The support can be computed simply by support for savings implies checking can be calculated using the support that savings implies checking is simply how many times you have both savings and checking happening, that is 5,000, divided by how many times overall checking happens. In this case, well, support is simply how many times we have both occurring together, which is 5,000 over 10,000, which is 50%. Confidence is computed as confidence of savings implies checking. So both occurring is 5,000 over savings occurring, total savings occurring is 6,000. So 5,000 over 6,000 is 83%. Expected confidence is computed as if the expected confidence for savings implying checking is overall number of checking, that is 8,500, because the CK, which is on the right hand side of the equation, you simply want to find out what proportion of the observations have CK equals yes. So 3,500 plus 5,000 is 8,500 divided by 10,000, which is 85%. So expected confidence is 85%, confidence is 83%. Now lift is computed as the confidence over expected confidence, which happens to be less than 1. If it is less than 1, it's considered negative correlation, which means these two products do not kind of go together. So from a contingency table like this, we can actually also calculate confidence and lift calculations. Alright, so next few slides talk about the algorithm, which I'm going to skip, and then there are a few other situations where a retail business person can use, for example, putting Barbie dolls and candies together, and it was found that people who bought Barbie doll also bought candies. So there are things they could put them together or put them far apart, so that going from one end of the store to the other and to find these two, they might buy something else in between, or you might want to package them for convenience sake, or you might package these three with maybe something that doesn't sell very well, kind of push that product out of the door. Or optionally, number 5, you can raise the price on ones and lower the price on the other, or maybe excuse me, or you can there are multiple different ways to come up with ideas for better sales and so on. Alright, and we will take a look at an example of a banking services data set, and see how to use SAS Miner for analysis. Okay, all right, and we will take a look at that. Thank you.